All right, so guys, 6.3 is confidence intervals for population proportions. Okay. So if you take a look up here, it says, in this section, we're going to learn how to construct confidence intervals for population proportions or probabilities of success known as P. Okay. The process similar to what we use to do the construct confidence interval for the means, but we're going to start with something called the point estimate. Okay. So the point estimate for the population proportion of successes is given by the proportion of successes in the sample. Guys, the way we read this little P with the little arrow on top, the way we read that, P hat. It's got a little hat on there, okay? So P hat. Where X is the number of successes and the sample size of N, and the point estimate for the population of failures, Q hat, is equal to 1 minus P hat. Okay, so look, let's see if we can figure this thing out here. Let's see. For the first part, in a survey of 883 American adults, 380 of them said that football or their favorite sport is football. Find a point estimate for the population proportion of adults who say their favorite sport is football. Okay, so guys, first thing I'm going to go like this. P hat equals. How many people did we look at here? How many people did we ask the question to? 883. That's my denominator, guys. Okay. Out of those 883, how many of them said, yeah, football is the one I like? 380. Okay. What we're going to do here, guys, we're going to take our calculator and we're going to divide, okay? So I'm going to turn it on. 380, oops. 380 divided by 883. And guys, let's go ahead and go to 2 decimal places. So if I go to 2 decimal places, what number would I write? 0.43. So again, guys, just to sort of think or understand what does that mean, it means that 43% of the people that we asked said football is their favorite sport. Okay. My question to you, Q hat, if 43% said that football was their favorite sport, how many did not say that? The rest, what would the rest be? Subtract, right? We take our calculator and go 1 minus 0.43, which should be 0.57. There we go, right? So guys, remember when I said the other day, like if Tim Smith says, hey, there's a 43% chance that it's going to rain, that means that there's a 57% chance it's not going to rain? Okay, same kind of thing here. That's Q hat, right? Because it's got the little goes up there, right? All right, so guys, let's do the same thing. I'm sorry? So the answer for the first part says, estimate the population proportion for adults who say football is their favorite. Which one liked football? The 43, right? So this is the one that liked football. Foosball. Right. These people here, not football, right? I don't know what they like, but I know it's not football. So far, so good? Did not like, right? They could have said any other sport, right? I don't know what they said, but they didn't say that football was their favorite. Okay. So guys, let's take a look at number 2. Okay. Number 2 says, in a survey of 2,462 U.S. teachers, 123 said that all or almost all of the information they find using search engines online is accurate and trustworthy. Find a point estimate for the population proportion of U.S. teachers who say online information is accurate. Okay, we're looking for the ones who say online information is accurate. That's my P hat. Okay. How many teachers did they interview? 2,462, right? That's the number that they surveyed, right? How many said, yes, I believe everything that you look up is going to be true? Only 123 of them, right? Yeah, we're going to go to 2 decimal places. So 123 divided by 2,462. So guys, if I go to 2 decimal places, what percent would you put? 0.05, okay? Okay, so here's my P hat. Only 5% of the teachers that they surveyed said, yes, everything you look up online is going to be either all or almost all true. My question to you, what percent of the teachers said, no, I don't believe that? 0.95, right? Okay, there we go. Okay. You don't have to write it. I just want you to understand that that would be the rest of it, right? All right, so now let's take a look at the next part here, guys. Confidence intervals for population proportions. Okay, so guys, remember, isn't this how we've been finding our confidence intervals before? We've been taking our mean and we either subtract the error or we do what? Add the error. Okay, so now look, the only part that's going to be different than what we're going to be doing here, well, how we find the error, right? It's different from how we were doing it before. Okay, so this is how we're going to find our error for these problems. It says the probability that the confidence intervals contains P is C, assuming the estimation process is repeated a large number of times. Guys, one thing I want you to notice, what's the variable that we have right here? ZC. Isn't that what we did today on our quiz? Wasn't that question number 1? Okay, so let's take a look at question number 3. Question number 3 says, construct a 95% confidence interval for the population proportion of American adults who say their favorite sport is football. Okay, so guys, before I do anything else, I know that my confidence level is 95%, right? Which is the same thing as 0.95. If you remember, guys, on the quiz, the first thing I said to do, and I even gave you the picture, was draw this here, right? What's the area on the inside? 0.95, right? So doesn't that mean that we have what percent left over for those two pieces? 5%, right? So guys, remember, as a decimal, 5% is 0.05, right? But because I'm going to have two pieces, I'm going to divide it by what? By 2. So what's going to be the area to the left? There we go. So we know that the area inside here is 0.025. The same thing over here at the end, right? Okay, so guys, remember, when I'm using my inverse t, or inverse z, or inverse norm, whatever, I'm always finding the area which way? To the left. Okay, so let's go like this. ZC equals, okay, I'm going to take my calculator right here. I'm going to clear it out. I'm going to go second bars, right? I'm going to go to inverse norm. And the number we're going to type in is what, 0.025? Okay. And guys, remember, we're going to go to 3 decimal places because on that chart we had 3 decimal places. 1.95 or 1.96? 1.196, right? 1.956, sorry. 1.96, there we go. Boom. All right. So now, let's come back and let's look at the error formula, guys. So first thing I'm going to do, I'm going to copy this formula right here down over here just so that I have it, okay? So I'm going to copy it for you. I mean, I know you can see it on your notes. I can't see it right now, but I know it's E equals ZC times the square root of P hat, Q hat, all over N. Does that seem right? Okay. So let's come back at problem number 1. What was our P hat in number 1? No, in number 1. Number 1. Point what? 0.43. Okay, so guys, when I come back over here, I'm just going to write this down just so that I have this information, right? We know that our P hat was 0.43. Wasn't our Q hat 0.57? Okay, so we're going to say, look, let's find our error. We're going to take 1.96 square root of 0.43 times 0.57, all divided by, what was our N? 380, no, was it 380? 883, right? Because how many people did we ask? We asked 883 of them, ¿verdad? Okay, so guys, for problem number 3, our N should be the number 883. That's how many people were surveyed. Okay. All right, so let me show you how you're going to do this on your calculator. First thing I want you to do, bust it out, okay? Let's clear it out. Okay, guys, on my calculator, the first thing I would probably do, 0.43 times, what's the next number I'm going to multiply? 0.57, okay? Equals, divided by what number? 883, okay? Equals. Now, what am I going to do with that number? We're going to take the square root of it, right, guys? So, guys, I'm going to go like this. Second square root, and it opens it up. What I want to type in there, I want to put my answer. So I'm going to go second, and right above the negative sign, there should be the answer button. Okay. So far, we good? Okay, anybody got any questions? Okay, and then hit enter again. Okay, so guys, we just did this piece right here. What are we going to do with that number? Times 1.96. I'm going to tell you right now. Un momento, por favor. Okay, so look, guys, when we were doing our p hat and our q hat, how many decimals did we use? Let's use 2 here también. 0.03. Okay, so we found our error. Okay, now I want you to look at how we're finding our confidence interval. This thing keeps getting tangled. Okay, guys, here's my confidence interval. Look what we're going to do. P hat minus E, and the proportion is going to be between P hat minus E and P hat plus E. Okay, so I'm going to go like this. There we go. P hat minus E, P hat plus E. Okay, P hat, what's in P hat? 0.43 minus 0.03 and 0.43 plus 0.03. Excuse me. Okay. So you're coming up with 0.40 and 0.46. Does that seem reasonable? Yeah, we're good? Okay, so let's come back to the calculator. Okay, let me clear it all out. Okay, so remember, the first thing I'm going to do here, I want you to think about the order of operations. Guys, remember, like, first day of school, order of operations, PEMDAS, please excuse my dear Aunt Sally. Remember all that stuff? Do you remember what the P stood for? Parentheses. Okay, I want you to think of all of this here, since it's inside the square root, think about that's your parentheses, okay? So look, we're going to go 0.43 times 57? Okay, equals, then we're going to divide it by 883 equals, okay, and now that we have that, we are going to square root our answer. So the way I'm going to do the square root, guys, I'm going to go second, hit my square root, and I want to get that number in there. So I'm going to go second and the little negative sign so that it'll type in my answer already from the previous line, ¿verdad? And close it off, hit enter. So we've done all of this business right now. We already did the square root and everything. Now, don't we need to multiply it by 1.96? And there we came up with that. We good there? Okay, there you go, you got it. Okay, so guys, yeah, it's recording. Let's see. Yep. I don't want to tell you yes and I wasn't sure. Okay. What was this TV? Okay, so guys, now the way I'm going to write my answer, I'm going to write it with the interval because I think in your homework it asks you to write it like this. So there we go. Now, guys, a little while ago, Anna said, okay, what are you going to round to? So when you're doing your homework, guys, look at what the directions are telling you, right? So when we did our error here, when we came up with our error, Anna said, what are you going to round to? I said, I'm going to go to 2 decimal places simply for the reason that my p hat had 2 decimal places, right? But if I'm doing my homework and it says, hey, round it to 3 decimal places, the only thing I would have done differently, if I would have gone to 3 decimal places here, guys, 0.032 or 0.033, that would have been the only thing I would have done differently, okay? And all you got to do is look at what the directions are telling you. If it's telling you, hey, round to 3 decimal places, then for your error, you should put 3, okay? All right. Let's see. So it says the result is usually not stated as a confidence interval. Sometimes we would say it's a 43% with a margin error of plus plus or minus 3.3%, right? All right, let's do the same thing for number 4. So let me grab my pen again. Now look what number 4 says. Construct a 90% confidence interval. Okay, so number 4, I'm going to look at a 0.90. For the proportion of U.S. teachers who say all or almost all the information they find online is accurate or trustworthy. So guys, the first thing I need to do here, the area on the inside is 90%, right? What's the area that I have left for both those pieces? 10%, but each one would be 0.05, right? Very good. Okay, so guys, remember the first thing we're going to do, we're going to find our ZC, right? So I'm going to turn on my calculator, I'm going to clear it out. Sorry. All right. That's going to be a little loud on the video, guys. I'm not gonna lie to you. All right, inverse norm. What is my area to the left? 0.05. Very good. Yes, because think about it this way. So remember, since we did this piece right here, right? This one is always going to be the negative one, and this one will be the positive one, right? So we came up with 1.64. Was it, if you would have gone 3 decimal places, would it have been 1.645? Okay. And so this one would have been 1.645. Now, guys, the only reason that I'm going to tell you, hey, why should I use 3 in this case instead of 2 is because if I go back all the way to the first page of my 6.1, isn't it right there? Do you see how it has the 1.645? So guys, remember, on your notes, I mean, do you have to do that little confidence interval every time? Not for these, right? Because those values are already there. They're already kind of determined, right? But instead of a 90%, suppose it would have said a 92%. Well, then you got to draw the picture and find it, right? But because it does give me some of those already, I want to go ahead and use what's there. So let me come back. Let's see where we is. Where más aquí? Here we go. Okay, so there's our 1.645, okay? Now we're going to find our margin of error, E. So guys, I'm just going to copy down the formula, which the one we just used a little while ago. Remember, that was my P hat, my Q hat, and my N. Okay. So guys, from problem number 2 with the teachers, do you remember what the P hat number was? On number 2? 0.05, right? So doesn't that tell me that our Q hat had to have been 0.95? Okay. The teacher one, right? So look, I'm going to go 1.645. Okay. Big old square root right here, guys. 0.05 times 0.95 divided by how many teachers did they ask that question to? 2,462? Okay. So guys, ayúdame, por favor. What am I going to do first on my calculator? Okay, so what should I type in first? 0.05 times 0.95, okay? And I'll hit equals, okay? And then I'm going to divide it by what number? 2462, okay? And I'm going to hit equals again. Okay, guys, do you remember how I do the square root of that? Second x squared to get my square root, and then second answer to get, or the little negative to get to my answer button, right? Close it off, hit equals, and we come up with that number there. Now I'm not done yet, right? What do I still need to do? Times 1.645, right? Okay. And so guys, on this one here, I'm going to go at least 3 decimal places. I don't want to go 2, because what are the first 2 numbers? Okay, so let's go 3 decimal places. Let's put 0.007. Okay, if I would have done 2, I agree. I would probably put 0.01, but I'm just going to go 0.007. Okay? I don't know what it's going to ask me for, but I probably, like I'm thinking about it out loud now, guys, as I'm talking to you, I would probably always do 3, and then if the answer tells me write it as 2, then I can round it then, right? Okay, so guys, remember how we're going to write our interval. We're going to go P hat minus E and P hat plus E. So 0.05 minus 0.007 and 0.05 plus 0.007. Okay. So let me take my calculator. 0.05 minus 0.007. 0.043. Okay. So I'm going to go like this, 0.043. And then, isn't the other one going to be 0.057? 0.057. And you got it. What do you think? Are we doing okay so far? We're all good? Awesome. Yeah, it's very similar, right? The process is the same? Same? All right, guys, so let me ask you a question. How would you do this problem here? What are we going to do? What are we going to do to find our p hat? Anybody know? You just said it. Add them and divide by 2. Okay, Adam and Eve. Let's see. Come back over here. So I'm going to clear that out. I'm going to go 0.712 plus 0.740 and divided by 2. 0.726. Okay. 0.726. Okay. And then now we wanted to find our error. What do we do, guys? Subtract one of them, right? So let's take, I already got that one there, so can I just go minus 0.712? Oops. And doesn't that give me 0.014? You could do it that way too, and you should still get 0.014, right? Right, so if you take 0.740 minus 0.726, do you get 0.014? Yeah, and think about it this way. Jackie, couldn't I also take 0.726 and minus that number there, and I would still get 0.014? Because that's the number that's right in the middle, right? So this is telling me, look, here's 0.726. If I add 0.14, I end up with 0.740. If I subtract 0.14, I end up with 0.712, right? Okay, so guys, the last part here, it says, as before, one way to improve the precision of an estimate without decreasing the level of confidence is to increase the sample size. But how large a sample size is needed to guarantee a certain level of confidence for a given maximum error of estimate? Quién sabe, but there's a formula right here for us. So we're going to go ahead and use that one. So let me highlight my formula right here. Okay, so guys, look at what the directions say. It says, this is what we're going to do, assuming we have estimates for p hat and q hat. What happens when we don't? Look at the estimates we're supposed to use. If they don't give me the estimates for p hat and q hat, I'm going to say that they're both 0.5. Okay. Now it says you're running a political campaign and you wish to estimate with a 95% confidence the proportion of registered voters who will vote for your candidate. Your estimate must be within 3% of the population proportion. Find the, let's see. Find the minimum sample size needed. A, if no preliminary estimate is available, and the preliminary part B, preliminary estimate gives us p hat to be 0.31. Okay, so let's do this. I'm going to write down my formula. N equals p hat, q hat times ZC all over the E squared. Okay. Guys, look at the first part. It says, no preliminary estimate is available. If we don't have preliminary estimates, look what we're going to use for p hat and q hat. They're both going to be what number? 0.5, right? So we're going to go like this, look. 0.5 times 0.5, okay? Now, I need to find my ZC. Guys, would you all do me a favor? If you go back to, look at the first page of your notes. 1.96? Is that the one they give us for when our confidence level is 95%? Is the ZC value 1.96? Everybody agree? And just to give you a heads up, guys, where am I finding that? All I'm doing is going right there at 95%. Isn't our ZC 1.96? Okay, so just to kind of give you a heads up again, right? You don't have to use like the inverse norm every single time. Use the standard ones that are given to me, right? Okay, so look, 1.96. Okay. Now, guys, my error is going to be, sorry, let me get rid of some of this red here. My error is going to be the 3% of the population. How would I write 3% as a decimal? 0.03. Okay, now this is going to be squared. Okay, so guys, we're going to do this on our calculator, right? And we're going to do it just like we were doing the other problem. So let me grab my calculator right here. Okay, my question to you, think about order of operations. What we did in the first day of school in August. What should I do first? Parentheses. Okay, so what number am I going to type in? 1 point what? 96, very good. We're going to divide it by what number? 0.03. Okay, I'm going to get equals. Okay, there we go. Now, what do we need to do with that number? We got to square it. So, guys, we're just going to hit the x squared button, right? Answer squared equals. Boom, massive number, 4,268 point, a whole bunch of fours. Okay, now we still got to multiply that number by what? 0.5, okay, equals. What do we got to do after we multiply by this 0.5? Multiply by that other 0.5, right? So 0.5 again. Okay. And, okay, I'm coming up with this number here, guys. So n is, if I were to round to the nearest whole number, would you say 1,067 or 1,068? I'd say 67, but I know the other day I was helping Rita with a problem, and it said something like round up, okay? So I'm going to do this. I'm going to say that my answer, depending on what my math lab is going to ask you to do, okay? If it tells you to round to the nearest whole number, then obviously we would say 1,067, right? But if the directions tell you round up to the next whole number, then the answer would be what? 1,068, okay? I just want you to pay attention to the way the directions are written, okay? So far, are we okay with what we've done so far? Okay, so guys, there's a second part to this problem, part B. Okay, oops. Okay, there's a second part to the problem, part B. And in part B, I'm still using the same formula that we did before. Except what part? There we go. Okay, so now in this case, our p hat is a 0.31, right? So guys, my question to you is that if my p hat is a 0.31, what would my q hat be? But hold on, remember, we got to subtract it from what number? From 1, right? So if my p hat is a 0.31, my q hat would have to be a point what? 69. Guys, remember, these two numbers here have to add up to what? 1, right? Okay. So wouldn't the rest of it, though, be the same thing? Yeah, because see how the problem here, Myra, was telling me there was a part A and a part B? Right. So we're just doing the part B now. The part B just says, look, let's use that part now. Okay. So guys, I'm going to grab my calculator one more time. Okay. And just like we did earlier, we're going to take the 1.96 divided by the 0.03, and then we're going to do what with that number? We're going to square it, right? Okay, so there we go. And now we're going to multiply it by 0.69, and then we're going to multiply it by 0.31. Okay. It doesn't make any difference which one multiply with first. Okay, guys, did you come up with 913? Okay. So again, if it tells me round to the closest whole number, I would put 913, right? If it says round up, then I would have put 914, right? That doesn't look like an up. There we go. And we got it. And I want to say that's the last problem in 6.3, isn't it? Boom! Check us out. ¿Qué tal? All right.